Okay, so used to describe the distribution of the data. What does that word distribution mean? Have you ever driven down the interstate and you see, like, on the side of the road it says, like, Walgreens Distribution Center?
Yeah.
Okay? What does distribution mean?
Tell them the location or something.
To distribute, which means to give or to spread out. Okay? So when we talk about measure of variation, variation means different or change. We're talking about how the data is distributed, how it is spread out. That was a great term. I like that. Actually, I'm going to put this to the side. I like Hayden's term, spread out. How the data is spread out. All right? So now, let's look at quartile. Has anybody found it in the glossary?
It's right here.
Oh, but you saw it on that page? Isn't that awesome? All right, so somebody read what it says about quartile.
Or values that divide the data set into 4 equal parts.
Okay, so we're going to write exactly that. Values that divide the data set into what?
4 different parts.
Into 4 equal parts. Think about that word quartile. What do you hear there? Quart. What else? Quarter.
Tile.
Not so much. Really focusing on the root word there. How many quarts are in a gallon?
4.
4. How many quarters in a dollar?
4.
4. So we're splitting our data into 4 equal parts. Okay? And we can think about quarter here. Alright, I think we may still be on the same page, right?
Right here in the middle.
Okay, Copeland, read that one for us. Lower quartile.
The median of the lower half of a set of data is the lower quartile.
Okay, so we're going to say median of the lower half. I think we're good with that. Median of the lower half. And you can abbreviate that LQ. Okay, we're not going to be writing lower quartile every time. We're going to refer to that as the LQ. So if the lower quartile is the median of the lower half, what do we think the upper quartile is?
The median of the upper half.
You got it. Median of the upper half. Now, what was median again? Middle. Median is the middle. Okay? So basically what we have now done, we have the median. We split it into 2 chunks. Now we're going to take the median of the upper half, the median of the lower half, and when we do that, we now have 4 chunks, or 4 quartiles. Okay? Somebody find, is it on that page, the interquartile range?
Yes.
All right, read that one for me, Macy.
What was on this page?
Yeah.
The range of the middle half of the data is the difference between the upper quartile and the lower quartile.
Okay, do you remember what range was from last week? The distance between. So now that we're doing interquartile range, it is the distance between the LQ and UQ. Between the lower quartile and upper quartile. Now, last week, remember we talked about measures of, do you remember, not variation, but had to do with how the data falls around the center. Measures of central tendency, okay? So how it falls around the middle. Now, this week we're starting with measures of variation. Now, we talked about range last week because it falls in nicely with mean, median, mode, and range. But range is really a measure of variation. It's how the data changes, how it's spread. So what was our definition of range again? Because this is the second time we've had this one. The highest and lowest value, right? So here we go. The distance between the highest and lowest value. And we know that's in a data set. So again, range, we talked about it last week, but we're going to talk about it again today just because it falls in with measures of variation. The range doesn't deal with how our data falls around the middle or the center. It deals with how it's spread out. And the last word we want to talk about today is called an outlier. All right, let's look for that definition. Do we happen to see it? I think it may have actually been in the...
It's in the 8. I found it.
You found it? Okay, what does it say?
An
Outlier.
outline is a data value that is either much greater or much less than the median.
Okay, so data value that is much greater or much less than the median. Look, we're going to translate this into our own words, and I'm going to say it doesn't fit. So when we look for the outlier, we're going to look for something that doesn't fit. Okay? Do me a favor real quick. I'm trying to think. I want to show you something, but I want to do it. Let's see if we can pause this real quick. Hang on just a second. Yeah, we're going to try it again. No, that's going to freeze right here. Pause, you think? Let's try it. Okay. So, we're going to be looking at some data sets and trying to figure out. But like that, with that data set, I would have been the outlier because I didn't fit. All right? Let's look at the bottom. Here we go. Talking about wind speeds. Okay, the average wind speed for several cities in Pennsylvania are given in the table. So first thing we're going to do, who remembers what do we do with all of our data before we do anything? What have I got to do? I've got to put, you got it. So we're going to put it in order from least to greatest. What is my smallest value up here? 7.5. Okay. I'm going to come over here and mark it out. What's next?
7.6.
All right. Okay.
7.8.
There is a 7.7. Okay. What you think next? 8.9. And then we've got 9, 9.5, and finally, there's a what? I got it. And then 9.5, and then 11.0. Okay. So that is our data set in order from least to greatest. The first thing it's asking us to do is find the range. Okay? So what is the range? How do we find range?
Just the highest and the lowest.
Okay, difference between the highest and lowest. So that would give us what? 2.5 plus 7.5 will get me to 10. So it would be 3.5. So our range is going to be 3.5. Okay, now the next thing it says find the median, all right? When we're looking for the upper and lower quartiles here, we always have to find the median first. So how many numbers do we have? 1, 2, 3, 4, 5, 6, 7. Okay, so what is our median going to be? 8.9. When you do that, I want you to go ahead. That's our median. We want to identify it. Okay, so again, looking at your definition of lower and upper quartiles, what are we looking for? Lower and upper quartiles, what are we looking for? The median of the upper half and the lower half. Do you see how this is split in two sections? Okay, I'm not going to count my median because I've already identified it as my median. It has a job. So now I want to look at this upper half. What's the median of that upper half? 9.5. So this is my UQ, or upper quartile. So what would be my lower quartile?
7.6.
You got it. That is my LQ, or lower quartile. Now if you look at this, I know it kind of looks like more, but how many chunks of data do we have? 1, 2, 3, 4. Okay? If you take a candy bar and you cut it 3 times, you know how many pieces you have? 4. Okay? So when we're doing this, we're splitting it 3 times, which gives us 4 chunks of data, which goes right back to our quartiles, because we want to think quarters. All right, so our LQ is 7.6. Our UQ is 9.5. Now, the last thing we're looking for, our interquartile range, which I'm going to abbreviate IQR. All right, how do we find the interquartile range? You got it. We're going to subtract because we want the difference between our upper quartile and lower quartile. So 9.5 minus 7.6 will give us what? Not quite. 9.5 minus 7.6. 1.9. Okay? Now, I'm going to say something. If you look at your paper, guys, and you don't have all of this written down, then you're not doing what you should be doing at the moment. These are examples for you to go back and look at later. All right? So our IQR, which is the difference between here, okay? This is your IQR, and that will be 1.9. That means it's really less than 2 numbers difference between the upper half of your data and the lower half of your data. Okay? All right, yes.
What if the 11.0 be the outlier?
You know what? I would almost say yes, other than the fact that it's only 1.5 away, and these are 2 from here to here. So it does fall kind of close. But yeah, I mean, and that's the thing, like, to me, an outlier is just you look at it and you, right now, as you get older, there's like a mathematical formula for you to figure out the outlier. But right now, I want you just being able to look at it and go, whoa, that number does not fit. If this were 40, then absolutely that would be an outlier. I would say in this set, we really don't have one.
Will we have to add the mean too?
The mean? Eventually we will. We're not going to worry about it today. But yeah, eventually, like, you're going to be so smart statistically. You're going to be able to go through and do the mean, median, mode, range, upper quartile, lower quartile, inner quartile range, outlier. Like, we're already up to 8 things so far you can do with one set of data. So yeah. All right, let's flip to the back. Okay? Let's look at this. The heights of several types of palm trees in feet are 40, 25, 15, 22, 50, and 30. Okay? The heights of several types of pine trees in feet are 60, 75, 45, 80, 75, and 70. So, this is compare and contrast the measures of variations of both kinds of trees. Variations. So, we're going to talk about what we just did. So, what am I going to do first with this set of data? Put it in order. So, here we go. We've got 15, 22, 25, 30, 40, and 50. Okay? I'm going to split this in half right here. I'm going to go ahead and list these others in order too. What's my smallest one here? 45. And then we've got 60. 70. 275s. And 80. Okay. Here we go. So, what is my first thing I want to find here? The range. You're right. I forgot range. Yep. So we got to do range, median, and then we want to do upper quartile, lower quartile, and then inner quartile range. Looking at this one, what do you think? Do we have something that might be an outlier?
50.
Think 50? 50 is only 10 away from this one.
15.
You know, I would maybe debate that 15 could be. Yeah. But then again, if I look at this, okay, so let's first of all, what's our median? Where's our median going to fall?
In the middle. Oh, so it will be 25.
It's in between 25 and 30. Here's my median. So remember what we have to do? Add those together. Divide by 2. 27.5? Okay. To me, if I look at this, those are pretty evenly spread from the median. Like 15's not too far from 27.5 and 50's not too far. Okay, what about my range?
15 minus 15.
Yep, which would give us 35. Okay, what about my upper quartile?
The upper quartile would be 40.
Yes, and look, let me show you why. Remember earlier we didn't use the median that was in the middle? Why do I get to count this number?
Because it's in the middle of the
It's right. These are in the median is actually in the middle of those two numbers. So I haven't used 30. 30 has not done anything for me yet. Okay, because my median is in between 30 and 25. So this is my upper half of my data. So what's my upper quartile? 40. Okay.
Your lower quartile would be 22.
Lower quartile is 22. You got it. So what's my inner quartile range? 18. And again, I would probably say, what do you think, Ms. Jessel, on this one? No outlier?
I don't think really.
It's kind of evenly spread. Like, it's not anything that really majorly sticks out. And that's what I want you looking for, is what majorly sticks out, okay?
If this were a test and like it's evenly spread out, is it okay if we still put an outlier, or would that see kind of wrong?
I want you to, you'll see, we're going to get to some in just a minute that you're going to be like, okay, yeah, that's really an outlier. So yeah, you'll be able to.
15 is 7 less than the 22, and only 10 less than the 25, which is the next number.
Exactly.
And the last 3 are spaced by 10s.
Yeah.
So I think
It's pretty evenly spaced out.
there's nothing that obviously would 45 be an outlier.
Because if we look at this, well, I still say these are pretty, because we're only talking 35 numbers difference between the highest and lowest. All right, let's look at the next one, because then we got to talk about the differences. So again, we need, what is our median?
70 and 75.
It's going to be between 70 and 75. So what would that give us?
70.5.
Not 70.5. Be careful. You got to add them together and divide by 2. Guys, this is the point. Don't 72.5. Don't be afraid to use your calculators at this point. Oops, sorry, I didn't mean to do that. Okay. All right, let's look. What would be our range?
35.
35. Very good. Okay, what about my upper quartile?
75.
75. Okay. What about my lower quartile?
60.
60. Here's my lower quartile. And my inner quartile range?
15.
15. You guys have got it. Now, looking at this data, okay, what could you say about pine trees compared to palm trees?
There's way more pine trees.
No, they have the same number that we surveyed. Look at your median height.
Oh.
You could generally say pine trees are what? Much taller. Okay?
Not just much taller.
Look at this. My interquartile range is at 70. Lower quartile is at 60. But look at your interquartile range. Pretty similar, right? So there's not a whole lot of variation in the sizes. There's not a whole lot of difference between, look at your range. It's exactly the same. But you could say, in general, pine trees are much taller than palm trees. Okay? All right, let's do the next one together. The lengths and feet of various bridges are 88, 251, 275, 354, and 1121.
88 first.
Well, look at this. It says name any outliers in the data set.
Like that one.
Absolutely. Do you see how this one?
It's much bigger.
Much larger. Okay, we're talking a difference between 88 and 354, and then we jump up to 1,121. So my outlier would definitely be 1,121 feet. And that's the difference. If you look at these data sets, see, I mean, there's a little bit of variation, but what I want you looking for is, wow, that really does not fit. Yeah. Question? Okay. All right, look at the next one. The ages of candidates in an election are 23, 48, 49, 55, 57, 63, and 72. Name any outliers.
Not really.
Really?
23.
23. I agree. Look at this. We jumped from 23 to 48, but everything else is like 48, 49, 55, 57, 63, 72. 23, to me, would be a huge outlier. Okay? This is all you do. Good. To me,
I knew it because it was the smallest number.
right, they're already in order. Now, here's the other thing I want to say. A lot of these things that sound difficult, don't overthink them. You're basically, when you're doing your upper lower quartile, you're finding the median 3 different times. Once you do that, then you subtract to find your interquartile range, and that is it. Could be. Now, let me talk to you about one more thing, and then I'm going to let you start on some practice, okay? Because we only have about 7 more minutes. Okay, if I have a set of data, so far the ones we did today had 7 numbers, okay? Or I think one had 6. Now, what happens if I have 8 numbers? And we're just going to do this. So 1, 2, 3, 4, 5, 6, 7, 8. Do write this down because you'll need to see this in a minute. What is my median going to be? It's not going to be 4.
5.
It's not going to be 5.
8.
Median. Where's the middle?
9. Because you add
9 divided by 2. It's going to be in between 4 and 5. So my median is 4.5. Now look what happens. I can use 5 over here because it's not my median. And I can use 4 over here because it's not my median.
range is 7.
So when I'm looking for my upper quartile and my lower quartile, what happens? I now have even sets of numbers on both sides, don't I? So where would my upper quartile be? It's going to be,
Lower quartile's 2.5.
somebody said it.
7?
It's not 7. Where would the middle be?
I know it's 5.
Between 6 and 7. So guys, there's a chance you may have to do the same thing we did with our median. So what would my upper quartile be?
2.5.
6.5. Okay?
2.5.
And lower quartile will be 2.5. So there may be a time when you have an even set of numbers that you have to do the same thing we did with the median. Okay? And that would be you would have to add the 2 together and divide by 2. So if you did that, what would your interquartile range be? It's okay.
I put 3.
6.5 minus 2.5. 4. Okay, yeah, your range was... I wasn't so worried about the range. I wanted to make sure and show you that because you're finding the median, there may be a time where you have to split those two numbers or add them together and divide by 2. Okay? All right, let me stop this.